Alrighty, folks. So we're going to do a little bit more HVAC here, based on a situation I have coming up in the summer with my GM Frigidaire. That was a confirmed acquisition along with the Comfortaire. So I'm still waiting on the Comfortaire as of right now. Hopefully we'll be getting that soon. So we're going to try to get that GE sold. Somebody who wants to fix it up, get a new plug for it. And then that one right there is going to the junkyard, because it's not worth repairing it, so I already got a guy set up for that. But anyway, that's not what this video is about, obviously. This video is how to ohm an air conditioning compressor. So in this case, we're going to be showing you how I do these tests on when I acquire these vintage units. And I hope you guys will find this useful for when you do start collecting vintage air conditioners and you want to test the compressor, see if it's faulty. So I'm going to show you guys how to test an air conditioning compressor. So obviously right now you're looking at my Fetters AJ compressor, which is an AJM 15-94. And so I'm going to grab my volt ohm meter, and I'm going to show you how to do some of these tests to determine whether or not your AC compressor is faulty. So what I'm going to do is we're going to go ahead and start off by determining does the compressor work, which we know in this case, yes. With the GM Frigidaire, yes, because I've heard it running before. So anyway, let's go ahead and start the test. So let me go ahead and readjust my light here so you can see a little bit better, and let's have some fun. Alright, so we're going to go ahead and put you guys here so you can see the compressor and its wiring. And I know you guys won't be able to see my volt ohm meter screen very well, but we're going to go ahead and show you exactly what I'm looking for. So right now I have my multimeter right here, and you can see we're set on mega ohms. So I'm just going to go ahead and switch it to ohms, because I'm going to do a continuity test. And we're going to see if my Fetters AJ has continuity. So we're going to test all possible pairings. So first thing we're going to do is we're going to test our start and our run, which is black to yellow. Oh, let's get good contact here. And we are getting 8.7 ohms, which is pretty low resistance, so that's good. So we're going to go ahead here and check again. So we're going to go black to white. Actually 0.8 ohms. So it's a pretty steady reading right there. So now what we're going to do is we're going to go ahead and test yellow to black. And we are getting a resistance of 8.9 ohms. So what we're going to do is we're going to go ahead and test yellow to white, which in this case we're getting the same thing. So now what we're going to do is we're going to test white to black. So we're going to go ahead and do that here. And according to my ohms meter, we are getting 0.8 ohms of resistance, which is very low resistance. And that is start to common. So we're going to go ahead and do the same thing here. So we're testing all possible pairings here. And we're getting 8.1 ohms on white to yellow. So in this case, we tested our compressor motor terminals, which in this case, they're good. So now I'm going to show you how to test an overload protector. So right now, because my leads are not connected to anything, we're getting what's called open line. So what that means is there's infinite resistance. So we're making sure we're unplugged. Yes, we are. So we're going to go ahead here and start off by removing our overload protector for testing. So what we're going to do is we're going to leave it connected. So we're going to leave this terminal connected to this one. But we are going to remove the incoming power, which is obviously our white common wire here, which goes all the way back to the control switch or to the control panel where the buttons are. So anyway, we're going to go ahead and secure our overload protector. And we're going to just gently wiggle it. And as you can see, it's starting to come off. But you want to be very careful that you don't accidentally break the wire. So what I'm going to do here is I'm going to go ahead and grab something flat that I can gently pry with in order to remove the terminal. Which in this case here, I do have something flat. I have a flat bladed screwdriver. So obviously do not do this while the air conditioner is on, and do not plug your air conditioner in, especially an older unit, if the overload protector on the compressor is removed, or if the fiberglass junction box door is removed, which is this guy right here. So anyway, what we're going to do is I'm going to grasp gently, and we're just going to push, push gently, just to loosen the terminal. Well, not loosen the terminal, but you want to push your spade lug off just enough. That way you can wiggle it off the rest of the way. Which you want to be very careful when doing that. You can see I was very careful, and now it's nice and secure. So what we're going to do here is we're going to set our common wire off to the side here. So we're going to leave it like that for now. And we're going to do another ohms test to see if the overload is good. So if the overload is good, you should get 0 or very, very low resistance. Which in this case we are going to test here across all the motor terminals. So we're going to go overload to black because we're going to go in order. We have 1.0 ohms. Actually 0.8 ohms. So that's a nice steady reading, which means we're good. We're going to go ahead and test common on the overload to yellow, which in this case we're getting about 8.3 ohms. And we're going to test the common, which is common to common, which in this case here we are getting 0 resistance. So on common to common you should get 0 resistance, but the other two readings should be in turn, along with the other readings you obtained during the previous test. So now what we're going to do is we're going to test the overload protector itself. So in this case we tested it on the compressor and it's fine. So now we're going to go ahead and reconnect our terminal here. So we're going to go ahead and just push that on like that. And we're not going to do a test just yet because we're going to put the junction box door back on before we do any kind of testing or anything. So in this case, I'm going to show you guys the wiring here for the compressor. So if we follow along our common wire here, so we're going to start with our incoming power first. As you can see here, power comes into the control panel here via the power cord and the thermostat. So when the thermostat engages, it's going to come along this white wire here, and then it's going to travel all the way over to this wire, along with that blue-green wire. And these two wires here are going to come to the compressor. So this common wire here hooks directly to the compressor to bring power in, and this teal wire here, or this turquoise wire, brings power to the capacitor to give it the charge needed to start and run the compressor. And then if we follow the path here, then the power from the capacitor goes through the black. So obviously it goes through our black and yellow wires, which our start wire is the black one, and the yellow wire is our run wire. So it comes in on these two here in sequence, while the power is constant, which is common. So the common, it comes in on the overload protector and then goes to the compressor. And the overload protector, which is this little guy right with this black little guy right here, that is a safety device. And what it is designed to do is designed to go when the compressor either gets too hot, or in that case it'd be overheating, or if you restart the unit too soon while the refrigerant is still moving. Because the compressor motor would stall out while the refrigerant is moving throughout the system, slowing down after a run. And it even says it on the control panel here, caution, wait 2 minutes before restarting. So that's what you want to do, is you just want to wait 2 minutes before restarting, and you should be good. So anyway, so that's our little wiring schematic here. So we're going to kind of go into a little more detail here. So like I said before, this white wire right here, this is your common wire, that which the power that goes to the compressor is going to come from the main control panel right here, and it's going to come along the white and the teal wire. And so the white wire, that delivers power to the overload protector, which then goes to the compressor via this wire right here. So then the teal wire, or as I always like to say, is turquoise, you know, but you might think it's teal, but we're just going to say it's teal, goes from the thermostat all the way to the run capacitor, which charges it. And then the black and yellow wires get energized by the run capacitor, which supplies the charge and voltage needed to start and run the compressor. So anyway, in our next video, we're going to show you how to decode the nameplate on a Tecumseh compressor. So anyway, I hope you guys found that video useful. This is lesson number 3, by the way. So before we close out this video, we're going to do one more test, which is testing for a short to ground. So if you've got a grounded compressor and you just know it's there, why not test it anyway? In this case, there is no short to ground, but I'm going to show you how to test for that anyway. So what we're going to do is we're going to use my meter once again. And what I'm going to do is I'm either going to get on a bare refrigerant line, or in this case, you want to either get on a refrigerant line or the metal itself on the compressor. And we're going to do each motor terminal in turn to see if there's a short. And what we're looking for is open line, which is what's currently reading now. So we're going to go ahead and do the test. We got open line on black. We got open line on yellow. And we got open line on common. So we know for sure this compressor is still good. There is no short in it, which means the compressor is still running strong and very healthy. So anyway, I thought I would show you guys how to do these kinds of tests, because once you start acquiring vintage air conditioners, you need to know how to do these tests, especially since it's very important, because you never know if an AC you've collected could be a potential hazard, such as like a shorted compressor, improper grounding protection. But anyway, my Fetters ground is right here. So in case if something should fail, like when the fan motor did, that will immediately go through the ground wire in the power cord, and it will quickly trip a circuit breaker and save the appliance. But anyway, I hope you guys found that video useful. And we are going to have a new playlist added. It's going to be HVAC lessons. So in case if you guys want to learn a little bit about HVAC, feel free to check these videos out and let me know what you think. And we are going to gradually continue to do more of these videos as I gain knowledge and experience. But anyway, thank you guys for watching. And we will see you in our next HVAC lesson, which will be number 4. How to tell. So our 4th video is going to be wiring. So anyway, hope you guys enjoyed this, and we'll see you in another video.